Okay, so on behalf of the CMU Portugal program, I would like to thank you, all the participants who have registered for the call. A special thank you to Professor Ashique from Carnegie Mellon University, Language Technologies Institute, for his availability to give the talk on social, cultural, and political biases through the lens of NLP. This talk will be a part of a series of talks that we have named Data Science Talks at CMU Portugal. They will take place during this month and March, leading up to the advanced training program in data science and machine learning that hopefully will be launched this year. The session will have 1 hour of duration, 45 minutes for the presentation, and 15 minutes for questions in the end. Please keep your microphone muted and camera turned off for the session. Should you have a question, please use the chat to question Professor Ashique, stating your name and affiliation. I will now give the floor to Professor João Magalhães from Universidade Nova de Lisboa to make a brief introduction of Professor Ashique. Thank you.
So, good afternoon to everyone. So, once again, and for the third time, it's my pleasure to welcome you all to this talk under the initiative Data Science Talks at CMU Portugal. So, this is a series of webinars that are being organized under the framework of the advanced training program for data science and machine learning in the context of CMU Portugal. And so this initiative is being jointly organized by CMU, Nova University, and IST at Universidade de Lisboa, and the Faculty of Sciences also at the University of Lisbon. So today we're here to listen to the great work that Ashique has been doing. So Ashique is a project scientist at the Language Technologies Institute at CMU. So he's mentored by Professor Tom Mitchell, and prior to this role, he was a postdoc mentored by Professor Jamie Carbonell at CMU. So Ashique's PhD thesis was also supervised by Professor Jamie Carbonell, and it was focused on distributed active learning. So currently, Ashique's research interests lies at the intersection of NLP and AI for social impact. And in this field, he is interested in analyzing globally important events in Southeast Asia and developing methods for noisy social media text generated in this linguistic diverse region. His other broad research focus in US politics, and in this area, his research involves devising novel methods to quantify, interpret, and understand political polarization. So thank you once again, Ashique, for being here, and please, the floor is yours.
Thank you. Thanks for this wonderful opportunity. Hello, everyone. Welcome to the talk titled Social, Cultural, and Political Biases Through the Lens of NLP. And I'm really excited about sharing this research. So in this talk, I'll be presenting three broad research directions. The first one will be social and cultural biases in popular entertainment. In the second part, I'll focus on political biases in contemporary US politics. And in the final part, I'll be talking about international conflicts and low resource NLP. Now, these three parts of the talk also has a thematic progression in terms of how the data and the methods are interacting. For example, the first one, I will be talking about new data, but I'll be using existing NLP methods. In the second part, I'll be talking about, again, new data, but we will be using known methods in a novel context. And in the final part, I'll be presenting work where, again, we are working on new data, but this time, new methods in very novel contexts. The data also has a similar thematic progression. In the first part, I'll be dealing with well-formed text. The second part of the talk deals with social media text, but the content is generated by English as first language speakers. And in the final part, it's the hardest challenge, I would say, where I'm dealing with social media text, and it's generated in a very multilingual region of the globe, and many of the speakers are non-native speakers of English. So now here I will start with the first part of the talk, social and cultural biases in Bollywood and Hollywood. Now, Bollywood, aka the Mumbai film industry, is huge. It has an outreach of 90 countries, a market share of $2.1 billion, audience of 1.2 billion people. However, there hasn't been much NLP and AI focused research on popular Bollywood content. And in this work, we are interested in this research question. On a diachronic corpus of popular entertainment, can we track social and cultural biases? The work that I'll be summarizing, these are coming from 3 different papers, and it's a joint work with Kunal Khadilkar. He's a very talented MCDS student. I have been co-mentoring him with Tom on an independent study, and he's been working with me for the last 6 months. And we will be focusing on affinity to lighter skin color, occupational gender stereotypes, and subtle biases. So our data is English subtitles of movies. And we consider a large span of time, spans 7 decades from 1950 to 2020. For Bollywood and Hollywood, we collect 100 top grossing films from each decade, which means we have 1400 movie subtitles. And our methods, we focus on a mixed method analysis consisting of a diverse set of techniques. We follow some count-based analysis, closed tests using language models, and biases in word embeddings. And I'll be discussing, presenting each of these one after one. So we first start with a very simple result. That is, we count the number of gendered pronoun usage. So male pronoun ratio is just a ratio of the total number of male gendered pronouns divided by the total number of male gendered pronouns and female gendered pronouns. And we compute this for Hollywood movies, Bollywood movies, and Google Books data. And as you can see that in the last 70 years, books data started with a very high male pronoun ratio, but it's now close to 50%. So that means both genders have roughly equal representation. However, we can see that both Hollywood and Bollywood are way above 50%, which indicates that film industries still have a lot to catch up with books in terms of gender representation. Now, we move on to some more analysis tasks using high performance language models. Pre-trained language models have improved state of the art in many downstream tasks, and some examples include BERT, ExcelNet, GPT-3, and so on and so forth. So we focus on BERT in this example. And BERT has the masked language model of BERT allows closed test, aka fill in the blank test. And one such example is, say, theory of general relativity was proposed by Mask. And if we input this to a language model BERT, then the output, it outputs outputs a series of words ranked by probability. And you can see that Einstein has the highest probability. So a recent work in EMNLP 2019 by Petroni et al. Investigated BERT as an alternative to knowledge base. And we have worked on a paper where we fine-tuned BERT on an Indian election dataset, and we tried to use BERT to mine political insights. So we fine-tuned BERT on this corpus, and we were asking that Mask will win. And then it will say some of the candidates ranked by probability. And we wanted to investigate if that can be used as an alternative to polling data. In this work involving Bollywood and Hollywood, we were interested if LMs can be, language models can be used to mine social and cultural insights. So for this particular experiment, we focus on two time periods, 1950 to 1970s. We call these like the old movie subset, and 2000 to 2020, we call this the new movie subset. And we use the following close test. A beautiful woman should have masked skin. And you can see that the masked word, if BERT is not fine-tuned on any corpus, it's just a pre-trained BERT, we use the BERT base, then there is no fair in the top 5 output words. But once we feed BERT Bollywood and Hollywood data, in both cases, we see that fair is the top choice. So we can see that there is an affinity towards lighter skin color in both Bollywood and Hollywood. We also investigate similar occupational stereotypes using close tests like a man should be masked by profession, a woman should be masked by profession. Our paper contains a lot of details, and we found that similar occupational stereotypes are found that a man is often, it says like soldier, the doctor, and for women it's like nurse, homemaker. So those kind of biases are present. But the next result I'll be showing is a more quantitative measure of this kind of occupational stereotypes. A little bit of background on word embeddings first. So word embeddings are a continuous representation of words in high dimensional space. And the intuition is words that appear in similar contexts are typically placed close to each other. So this technique is called word embedding association test. And what it evaluates is, given a set of professions and given a set of gendered pronouns, if the gendered pronouns are equidistant to this set of professions in the word embedding space. And it outputs a number, a measure to quantify gender bias in word embeddings. And the way to interpret this number is higher value indicates larger gender bias. So these are the result of this word embedding association test, or the WEAT score, for Bollywood and Hollywood over the different time periods. So old are 1950 to 1970, mid are 1970 to 2000, and new are 2000 to 2020. And we can see the WEAT score has gradually decreased over time. That means that there is a decreasing trend in bias across both industries. So which is an encouraging sign. Now we wanted to know that if critical acclaim or revenue, which one matters more? So all the movies we have considered for Bollywood and Hollywood, they are top grossing movies. They made a lot of money. We constructed a different set of movies where we only considered world movies nominated for the Oscar. And these are like foreign films, and we again use English subtitles. And when we compute the WEAT scores, we see that world movies have the least WEAT score among Bollywood, Hollywood, and world movies. So which means critically acclaimed movies exhibit less bias. We were also interested in seeing if the genre plays any role. So this is the breakdown of romance and action movies, and we find that again the WEAT score of the action movies are higher than the romance movies. So romantic movies are less biased than action movies, and Hollywood action movies exhibit the maximum bias. So these are some results on occupational stereotypes. But we were interested in digging deeper and looking into more subtle form of biases. We focused on a retrograde social practice, dowry, that is basically a financial transaction between the bride's family and the groom's family during marriage, where the bride's family offer offers financial asset to the groom's family. It's a retrograde social practice. It's prohibited by Indian law right now, but it's still, there are reports that it still continues. And the second aspect we wanted to look at is son preference. Like if a family, if they're expecting a baby, if they want it to be a son or a daughter. Now, son preference is also very well studied in the literature, in medical literature and social science literature. And given the history of sun preference in strong sun preference in India, in 1994, there was a legislation that was passed where before a birth, gender discernment was made illegal, so that people cannot know if it's going to be a boy or a girl, to prevent female infanticide and female feticide. Now, these two things are somewhat interlinked, because if dowry is a well established practice, then people will prefer to have son rather than daughter, because having a daughter means you will have to make financial arrangement for the marriage. So now we were interested to see how the perception of dowry and son preference, how these two things have evolved over time. In our first analysis, we aligned diachronic word embeddings using a recent technique. And you can see the nearest neighbors of dowry in 1950s are loan, money, fees, jewelry, debt. So these are more like words that kind of give a signal that someone is trying to arrange for those things. So there is some kind of compliance to it. But as time progressed and towards 2000, we see the nearest neighbors are divorce, refused, guts, this kind of words. So this indicates that the perception of dowry has changed, and it has become more negative as time progressed. Now, what has happened to son preference? So in this one, we used a very simple count-based technique. We tracked phrases such as congratulations, it's a boy, it's a girl, and we annotated if in a film, in a movie, a child is born, if the child is daughter or a son. And we compute a number called male birth ratio, which is like for a given time frame, how many times a boy is born in a movie divided by the total number of times a boy or a girl is born in a movie. And we wanted to track this ratio. And what we find is over the time, this ratio has now become close to 54.5%. So which means it's now nearly close to perfect 50%. So the takeaways are male birth ratio improved over time, and the response toward dowry also became negative over time. So the two things, the tacit connection between the two things are also somewhat reflected in popular movie content. In the work that we have done, we explored a lot of other directions of biases and several research questions. So we looked into if we can track economic signals, like can we predict inflation using language models. We also looked into geographic and religious representations. And we also did some preliminary study on generating dialogues using language models. And then we asked people from the film industry, like, can you tell if this is generated by a language model or if this is coming from a real movie? And some of the times we actually managed to fool even people from Bollywood industry. They thought that these dialogues are generated by actual humans, but what happened, it was generated by language models. So the big picture of this work is popular entertainment does reflect social and cultural biases, and we can use cutting edge NLP methods to uncover these biases. Some future directions include, we were very interested in tracking interactions between the rich and the poor community. And we want to see that how often a poor person becomes rich inside of the movie. So in that way, we can somewhat have an estimate of economic mobility. And we also want to know that, okay, popular entertainment reflects society, but society, but does popular entertainment also influence society in some positive way? So those kind of causal questions are our future research goal. So this is the first part of the talk where we talk about Bollywood and Hollywood. And now we move to the second part of the talk, which is no less interesting or dramatic, because we are talking about the US politics. So in US politics, we have seen a deepening political divide. So this is an example of mm, this is an example of a survey that was taken from 1994 to 2014, asking registered Republicans and Democrats policy related questions. And we see that their responses, as time progressed, either became very conservative or became highly liberal. So there is a growing difference, divergence between these two political groups. And the role of hyperpartisan news media and their partisan and ideological divergence in both content and audience is well documented. In this work, we focused on four major US news networks. Fox, CNN, MSNBC are well known. There are three big news networks. We also focused on One America News Network. It's a fringe conservative network. And the reason we focused on it was it has got tremendous presidential endorsement. Former President Trump used to tweet a lot about One America News Network, praising this network. So over the last 5 or 6 years, on YouTube, all these networks have official YouTube channels. And you can see that the average numbers of comments per news videos have substantially increased. And this actually resulted in a very rich data set of more than 85 million comments on over 200K news videos between January 1st, 2014 to July 31st, 2020. Now we collect this huge data set, but how do we shed light on polarization? How do we know if CNN discussion is any different from MSNBC discussion? If Fox discussion is different from CNN or MSNBC, how much different? And what is the most similar news discussion with Fox? So how can we answer these kind of questions? So the research question in this work is how to quantify differences between these large-scale social media discussion datasets. Our proposed solution takes a very intriguing path. So say we use CNN and Fox as examples, and we want to compute differences between CNN discussion and Fox discussion. So we assume that the two subcommunities are speaking in two different languages, language of CNN and language of Fox. In reality, they are speaking in English, but we assume that they are speaking in two different languages. And then we translate each word from language of CNN into language of Fox. Now, ideally, Apple in language of CNN should translate Apple in language of Fox. Tree in language of CNN should translate into tree in language of Fox. But here, we focus on word pairs that do not translate into themselves, which we call misaligned pairs. And when a misaligned pair, say suppose Democrats and Republicans, appear in similar contexts, they often signal political and ideological disagreements. So in this table, the blue columns are comments from CNN and the red columns are comments from Fox. So you can see that Republicans and Democrats appear in almost mirroring context. Republicans are the greatest threat to America. Democrats are the greatest threat to America. Republicans are traitors. Democrats are traitors. I'll never vote Republican again. I'll never vote Democrat again. So no wonder why if we use a machine translation method, the method will believe that Democrats in language of CNN translates to Republicans in language of Fox, and Republicans in language of CNN translates to Democrats in language of Fox. So uh, a little bit of background on alignment-based machine translation. So what happens is we have word embeddings of two monolingual corpora of two different languages. Um, Typically, these are like English, German, or Spanish English, like really different languages. And we have a set of anchor words like bilingual dictionary, where we say that, say, hola is hello, pescado is fish, gracias is thanks, lucha is fight, gato is cat. So using this small set of anchor words in the bilingual dictionary, the goal is to learn a transformation such that the embedding of source word, when we multiply that with the transformation, we get the embedding of the target word. So that's how alignment-based machine translation works. And here is a pictorial description of how it works. So on the left side, we see, say, 4, 5, 3, 1, 2. And in the right side, we see cuatro, cinco, o tres, o dos, and uno. And we try to learn a mapping so that if we take the representation of 4 and multiply it with the matrix, then we get the representation in Spanish. So this is how alignment-based machine translation works. And this is actually a 2D representation. Typically, these words are represented in very high dimensional space. So in our method, we have again two sets of word embeddings, say Fox and CNN. And we need to have this bilingual lexicon where we know that gato is cat or pescado is fish. But in this case, we are actually translating English into English. So how do we have this kind of anchor words? So we use stop words, say and or about as anchor words. So we say that and in CNN English is also and in Fox English, or in CNN English is also or in Fox English. And then we try to align them using a well-known alignment-based machine translation method. And once we do that, we try to count the number of misaligned words. Now, if two communities, if they are very different, then we will have lots of misaligned pairs. And if two communities have a lot of agreement, then most of the words will translate into itself. So it will have fewer misaligned pairs. So in that way, we can actually quantify how different these large-scale discussion datasets are. Before we quantify, we first look at some of the misaligned pairs from CNN to Fox. So in political entities, we have the usual suspects like Democrats, Republicans, GOP Democrats. We also have Kushner and Burisma. So Kushner is Trump's son-in-law, and Burisma is the company which had some kind of controversy, alleged controversy related to Hunter Biden, who is Biden's son. So we can see that there is a parallel between the allegation of nepotism in this misaligned pair. We also look at the insults. We see that Trump-tards and snowflakes translate into each other. So Trump-tards are the insult that people use to describe Trump followers, and snowflakes are the insult that people use to describe Democrats. And we see that these two insults map into each other. But we were very deeply surprised, and we were worried to see that KKK, which is a white supremacist organization, mapped to BLM, which is the short form for Black Lives Matter. And we wanted to see that why would this occur? And in the data, we found that indeed KKK is a hate group. In CNN, we get to see this kind of comments. In Fox, we get to see BLM is a hate group. We see KKK terrorists. We see phrases like BLM terrorists. KKK is nothing more than and BLM is nothing more than a. So this kind of phrases actually cause this misaligned pair. So KKK and BLM appear in almost mirroring context in these two different discussions. which is a very worrying sign, but our method actually helped us to find this result. Now, as I already said, that if the number of misaligned pairs are large, then the two communities are very different. So in this matrix, we are saying that how similar different news networks are. So say the number between language of CNN and language of Fox is 90.2%, which means if we try to translate CNN words into Fox, then 90.2% of those words translate into themselves. So we can see that from the first row, CNN is closer to MSNBC than Fox, because 94.2% of CNN words translate into MSNBC language. We also see Fox is closer to CNN than MSNBC. And from the final row, we see MSNBC is closer to CNN than Fox. So this actually allows us to put this into a political spectrum, ideological spectrum. Like if MSNBC is in the left, CNN is somewhere in the middle, and Fox is somewhere in the right. We can do the same thing with 4 news networks. There we find that MSNBC is in the right, then CNN somewhere in the center, then Fox, and then One American News Network is really far right. Now, this is not the only source of news available to US right now. Many people watch political comedies a lot. And we were interested to see that if we look at primetime comedians, go to their YouTube networks and collect a data set of comments on primetime comedy videos, what language do they speak? And in our analysis, we found that primetime comedy is closest to CNN, farthest from Fox, which again makes sense because Fox is conservative network and primetime comedy is mostly liberal, so it's closest to CNN. That makes a lot of sense. But beyond this fun result, we were also interested in looking into something much more important. We wanted to look at what is Trump's own YouTube network. What language do Trump followers speak? So this is a 7-way matrix between Trump's network and 6 different news networks. And we see that from left to right, if we arrange, then it is MSNBC, then CNN, Fox, Blaze, One American News Network, Newsmax, and Trump finally. So if we follow US news, then we would know that Newsmax and One American News Network were the 2 networks who were spreading maximum amount of voter misinformation. And we see that our analysis indicates that the language of Trump followers is linguistically closest to the language of Newsmax followers. And this is the analysis we conducted for the year 2020. And this is a new paper where we looked into the 64 days starting from November 3rd to January 5th, one day before the Capitol riot. Beyond this quantifiable framework and ability to compare large-scale discussion datasets, our method is very efficient because we don't need to read 3 million comments. If we just see that solar in language of CNN translates to fossil in language of Fox, we immediately know that there is a debate surrounding the energy issues. If we see that mask in language of Fox translates into muzzle in language of One American News Network, we immediately know that there is a debate surrounding how masks are interfering with some smaller subcommunities' freedom of speech. That's how they believe. And we can immediately figure out with this one misaligned pair. So we also looked into in some preliminary experiment of can we go beyond a single word? Can we start translating phrases? And again, we found a very deeply disturbing result. We found that Black Lives Matter in language of CNN is closer to All Lives Matter in language of Fox than Black Lives Matter. So the big picture is different words may be used in near identical contexts in different communities, and those words may inform us about fundamental differences between the communities. And machine translation methods can provide a powerful, interpretable, and quantifiable framework. Now, up till now, we are talking about differences. In the part 3, what we want to present is what to do about long-standing differences. So we focus on international conflict, and we focus on a situation where heated online discussions are happening between nuclear adversaries, India and Pakistan, at the brink of a war. In online space, the typical moderation effort is you detect and try to block hate speech. But when two countries are at the brink of a war, instead of detecting and blocking negative content, surfacing positive content, content such as content that are expressing peace-seeking, hostility-diffusing stance is equally important. So our research question is, can AI help in detecting peace-seeking, hostility-diffusing content? Now, a little bit of background on the conflict. We focused on an incident triggered by a terror attack, suicide bomber attack that happened on 14th Feb that killed multiple Indian soldiers. Soon after that, Jaish-e-Mohammed, a Pakistan-based militant organization, claimed responsibility for that, and diplomatic escalations started happening up until 26th Feb. India reported an airstrike in Pakistan and reported death of large number of terrorists. And then a Indian pilot got captured by Pakistan military, and the two countries came precariously close to declaring a full-fledged war. Up until the Pakistan Prime Minister declared that he would be releasing the captured pilot, Abhinandan, as a gesture of peace. The situation for the time being subsided, became somewhat normal. However, the long history of the conflict between India and Pakistan, it's an ongoing issue. And Kashmir is a disputed region since the inception of the two countries, which is one of the major reasons the two countries have been fighting for so long. There have been 4 full-blown wars, many skirmishes. Both countries are nuclear powers, and a full-blown war projects 100 million deaths. So this is a background of the India and Pakistan conflict. Now, working on NLP from South Asian, a very multilingual South Asian region, needs also some kind of background, like what are the challenges. So typically, much of its NLP research focuses on English content. And as a result, a large volume of data in highly prevalent first language is often ignored. For example, 500 million Hindi speakers reside in combined India and Pakistan. There is significantly limited resource for Hindi as compared to English. Also, 90% of the social media web content of Hindi is written in Romanized Hindi, Hindi written in Roman scripts. And Romanized Hindi has even sparser resource. Okay, and working on English data is not easy either, because multilingualism makes extracting a monolingual corpus a significant challenge. India alone has 22 languages recognized by its constitution, and many languages and their Romanized versions are not supported by commercial solutions such as offered by Google or Facebook. Also, there is the non-native speaker aspect. Because many of the speakers are non-native speakers of English, there is significant spelling and grammar disfluencies. For example, here, Pak PM, God bless you, my in pilot thanks you country. It's basically God bless you is God bless you, intended to be. Or there is a presence of code switching where multilingual people just seamlessly alter between multiple languages within the same document. So here it starts with thank you Pakistan for humanity, no war, and then Aman Shanti Kayam Kare is Hindi, which translates to let peace prevail. So all these challenges make NLP extremely difficult in South Asia. So this actually comes to two more practical research questions, like how can we extract a reasonably clean English corpus? And given linguistic resources in English, such as content classifier or labeled examples, how can we transfer resources to Romanized Hindi? So these are the two associated research challenges that we want to deal with. Now, our data is again comments on relevant YouTube videos, and we gathered a data set specific to this conflict of 2.4 million comments from more than 2,000 videos. Now, I'll talk about the second research question of extracting English. Our dataset is a YouTube corpus of comments authored in a diverse set of languages. And how can we extract a reasonably clean English corpus? Little bit of background on skipgram word embeddings. A skipgram embedding predicts an input word's context, and polyglot skipgram word embeddings is basically skipgram embeddings trained on a single multilingual corpus. Now, here's a very important NLP result that we found in this work is these polyglot embeddings can be extremely useful in identifying languages. So if we compute polyglot embedding for each of these documents, and if we cluster them, then we see precise monolingual clusters. For example, on the on the right side, we have 21 European languages from the Europarl dataset, that is parliamentarian discussions in Europe. And we clustered them and we see 21 precise clusters. And in the left side, we have a YouTube comments from Oriya TV. Oriya is a province, Orissa is a province in India. And we can see that the clusters are not that crisp as Europarl clean data, but even in the social media data, we can see that there is linguistic separation. Now, the best part of this method is up till the point of clustering, it is unsupervised. The only supervision is needed when you have a cluster, you randomly sample 10 comments, and an annotator labels all those documents with the language, and then we can assign that language to that whole cluster. So now when we have a new document, all that we have to do is we just have to figure out which cluster it is closest to, and that's its language. So to give you a number, for these 21 European clusters, we will just need to annotate 210 documents. It's that efficient. And how is the performance? And here we are comparing against fast text, that is Facebook's language identifier and Google's language identifier. So on this noisy social media set, our method beats even Google. But that's not the only advantage of this method. The advantage I already said, that in our India-Pakistan corpus, we processed 2.0.4 million comments with just like annotating 30 comments, so 10 comments per cluster. So that's how annotation efficient it is. And it has been adopted in other analysis. So we have a paper on Rohingya refugee crisis, where again, like we worked on a very multilingual setting. We had a paper on 2019 Indian general election and Chennai water crisis. And in all these cases, it was very useful. We may run into a situation where we have to detect language which is not supported by, say, Google or Facebook. Say Assamese. Assam is a province in India. It has more than 10 million speakers. But if you want to do any meaningful social science analysis with our L polyglot, we can build a language identifier in an unsupervised way, and we can detect Assamese. So these are the advantages of this method. As I said, that our first research question was how can we promote peace when two countries are at the brink of a war. So this brings us to the task of hope speech detection, where the research question is, can AI help in detecting peace-seeking, hostility-diffusing content? And we define this new hope speech detection task, which is a nuanced classifier detecting hostility-diffusing content. And some subcategories are, if a comment is hope speech, if it's expressing a peace-seeking intent, such as we want peace. If it's talking about the humanitarian cost of war, like peace is better than war as the price of war is death of innocent peoples, or if it expresses appreciation for neighbor, I'm from Pakistan, I love India and Indian people, and so on and so forth. There are many other subclasses that are presented in the paper. Um, we wanted to build a classifier that can detect a hope speech. So we constructed a data set of 2,200 positives roughly and 7,700 negatives. And we used n-grams and embeddings as features to train a classifier and detect hope speech. So up till that part, it is very typical NLP method paper would look like. But we were very interested in evaluating the performance in the wild. So we wanted to see that if we take a data set, take the part of the data which is neither a part of the training nor the part of the test set, how does our hope speech classifier performs? So we manually annotated the top 100 hope speech predicted by our classifier in the wild. And we found that not top 100, I think top 110 or something. So our classifier yields 84.7% accuracy on human evaluation. And if we perform random sampling, we will get only 2.5% hope speech. So that means using our classifier, we can bring in substantial improvement in web moderation. If there is a moderator, she won't be able to read millions of comments, but using our classifier, if the classifier predicts like these are some top choices of hope speech, then it will be much easier for her to decide if she wants to surface those comments or make them prominent in some way or the other. This is actually, we also did a detailed analysis of if the detected hope speech in the wild satisfy the different conditions we defined for this speech. So we found that the different categories are also well represented. Here are some examples of hope speech that we found in the wild. The bottom most one is very interesting because it's originally by Herodotus some 2,500 years back. And the fact that a YouTube user is reproducing this comment even after 2,500 years tells us that we haven't done much progress in achieving peace. This is a social science result I think people would be very interested in looking at. We created a set of phrases to identify if a comment is expressing peace-seeking stance or war-seeking stance, and we plotted them over the period of time this conflict happened. So as you can see that between February 27, 28 and March 1, when the two countries were precariously close to declaring war, peace-seeking comments were actually more than war-seeking comments. So when the threats of the war became real, we actually found that common people tended to gravitate towards peace. So which was a very interesting result, like a country with like a history of these many wars, people at least in this particular context wanted peace. And we also see the activity of the comments, like when the threat of the war became real, a lot of people started commenting, a lot of people started liking comments, and a same general trend was observed. Now it comes to the final research question that suppose we have an English hope speech classifier. Almost half of the data is Romanized Hindi. How can we transfer resources to Romanized Hindi? Using an English hope speech classifier, can we detect Hindi hope speech? Now here is an interesting observation. For people who do not understand Hindi, "Main aman chahta hu khuda ke vaste jang nahi" will probably not make any sense. However, the word like the phrase "I love India and Pakistani peace, peace, peace," we can identify that this is a peace-seeking comment. The fun part is this is the part of the same comment. And it's an example of code switching where the seamless transition of languages is happening within the same document boundary. Code switching is typically looked at as an obstacle to downstream analysis. However, in this work, we find that a short document is likely to express a consistent sentiment. So even if I don't know what "Main aman chahta hu khuda ke vaste jang nahi" means, from the English part, "I love India, I am Pakistani, peace, peace, peace," we can have an educated guess that maybe "Main aman chahta hu khuda ke vaste jang nahi" also means something peaceful. And if we can have linguistic separation of these two parts, then using this concept of sentiment parallelism, we can harness code switching to perform cross-lingual sampling for social good. So if we can extract the Hindi part and we say that find me something that is similar to "Main aman chahta hu khuda ke vaste jang nahi," chances are pretty high that we will find something also expressing peace. So consider we have a document level sampler of code switch comments and a precise word level language identifier. So what we try to do is we first detect code switch comments that are exhibiting hope speech. And what we since we have an English classifier, the English classifier can actually detect hope speech from the English part of these code mixed comments. And then we extract the Hindi part and we perform nearest neighbor sampling of the extracted Hindi part in Hindi region. So let's take a look at how it works in with an example. So we look at the same example. I love India, I'm Pakistani. मैं अमन चाहता हूँ खुदा के वास्ते जंग नहीं, peace, peace, peace. And turns out that L polyglot, the one that we use to detect document level languages, is very good at detecting words, languages at the word level as well. So L polyglot actually identifies मैं अमन चाहता हूँ खुदा के जंग नहीं as Hindi. It thinks vaste as West. But still, the noisy extraction, when we perform nearest neighbor sampling in the document embedding space, we find an out and out Hindi comment, which translates to I am a Rajput. I never want fight between the two countries. We were one country before the partition. Only a handful of extremists want bloodshed. So pictorially, this is the 2D representation of the document embedding space. We can see that the black region is the code switch region, the blue is the English one, and the red is Hindi. And the magenta triangles are code mixed hope speech. But once we extract the Hindi out of it and perform nearest neighbor sample, we find the obtained Hindi hope speech are all over the Hindi region. And if we just randomly sample Hindi comments, we will get 1.8% hope speech. And using this method, we have more than tenfold performance gain, like 23%. And this is just coming for free. There is no Hindi classifier. We are just using the English classifier and we are using code switching. And we are improving sampling performance by a factor of 10. So the big picture is we show a framework novelty where we amplify the positives as opposed to blocking the hate. L Polyglot is a software that is publicly available. It's a very useful tool, and code switching can be harnessed for social good. So these are the three broad research directions that we pursued. So what are some of the next ideas? So for Bollywood and Hollywood work, I have already said that we can try to track economic mobility in popular entertainment and see what we find. For US politics, we have a new paper investigating fringe news networks, where we focus on the 64 days between the November 3rd election and 1 day before the Capitol riot. For cross-lingual sampling, again, we have a new paper. It's on archive right now. We use unsupervised word translation instead of code switching, and we show even better performance. And one very interesting direction that I'm interested in right now is domain sensitivity of content classifiers. For example, can we use hope speech trained on India-Pakistan conflict and use it for a different country pairs or a different conflict? So we have a recent paper along this direction where we show that if you have a hate speech classifier and you run it on chess discussions, then since there are black pieces and white pieces and words like attack, threat, the hate speech classifier actually flagged many of the comments as chess discussions as hate speech. This has won the best AAI student abstract this year. And I am very fortunate to work with my mentors and collaborators. Professor Jaime Carbonell is my thesis advisor. He was the founding director of LTI. Mark Camlet is the former provost of CMU, and Professor Tom Mitchell is my current mentor. I was very fortunate to work with Kunal Khadilkar and Rupak Sarkar, my students, and my friend and collaborator Srifani Palakodeti. It's been a year since Jaime has passed away, and he has been a very strong influence in my research. Whatever research I have accomplished, the full credit goes to him. And this talk is dedicated to his memory, and I'm happy to take questions. Thank you.
Okay, thank you very much, Professor, for the interesting and diverse talk. So we have now one question already from Henrique Cardoso. Thank you for the very interesting talk. As a general approach, is it feasible to train a language model in unbiased text and use metrics of perplexity to detect biased content? Would this make sense in forensic linguistics tasks such as authorship detection?
Is the question written in any chat?
It's in the chat, yes.
It's in the chat.
Yeah, let me see. Is it feasible to train a language model in unbiased text and use metrics of perplexity to detect biased contents? Would this make sense in forensic language? Yeah, I think that would be a sensible direction. We are actually trying to explore this direction in one of our work. So and our preliminary results are encouraging. So yeah, I think this is a very reasonable direction. And authorship detection, I'm not very sure if it will be that powerful, but let me know if it works.
Okay.
So
we don't have any more questions, but yes, Professor, go ahead.
Yeah, I have several questions and ideas. So you made all this very interesting analysis, and I was wondering if you reached out to some social scientists or to political science people. What do they make of this, if you have?
Oh yeah, so the U.S. politics paper and the paper on Capitol riot, Professor Mark Camlett is a co-author. He's an economist and a political scientist. So
Okay.
We have already worked with political science researchers in the political polarization work, and for the work on gender bias in Bollywood and Hollywood, we have presented this work in the computational social science workshop in EMNLP, and we have got some very good feedback from
the community.
Yeah.
Okay. So also with respect to your work, again with respect to the political spectrum of CNN or MSNBC, from MSNBC to Newsmax or the other one after, I don't recall the name. So you in a way you need like an anchor in that spectrum, right? Don't you need to know who is in the center, right? Don't
so if we suppose in the case of 3 news networks, if we know that MSNBC is farthest from Fox, and Fox is also farthest from MSNBC, and then CNN is the distance between CNN, Fox, and CNN and MSNBC less, then the only logical way to arrange them is like MSNBC, CNN, and Fox. But we don't know whether we should put MSNBC on the left or Fox on the right. That is something that we are taking in.
Let me try to rephrase my question. So you know how they relate to each other, right? But
yes.
Can you measure which one is more neutral? Is there a way to know which one? Sorry?
We can measure which one is in the center, but neutrality kind of hard to measure, right?
Okay.
It's a pairwise distance, so measuring neutrality would be very hard.
Yeah. You have referenced news sources like the BBC and Reuters, so they in a way are more more close to neutral. So I have other comment. So this is again I find this topic very interesting, and so I have all these ideas. So it may be interesting, and I don't know if you've done this, to compare, for example, within the same news organization in different mediums. Like you have YouTube comments, but then you have Twitter comments, and you have the news on the website and the news on the TV. And have you compared to see if there is a difference between those?
So one limitation of our method is it needs a lot of data to build reliable word embeddings, right? So like if you just consider news itself, like what's being said, it won't be like in the order of 85 million comments, like the number of words you have in 85 million comments. So the word embeddings will not be very reliable. So that's why those analyses will be very difficult to do. But if we can scale it up, like if like 100 years from now, if we have like lots and lots of news videos or something, then I think those kind of analysis will be feasible. Another limitation of our work is when we are comparing, say, Fox, CNN, and MSNBC, the event space is the same. Like same American events are happening, those are being covered, and then people are talking about them, and people are talking about them in very different ways. Like they're saying, say, Republicans are responsible for some bad thing, or Democrats are responsible for some bad thing. So the bad thing remains the same. It's just the two political parties are being switched, right? But if we say look at BBC and the way BBC covers news, they cover all over the world. Like they have so many different events they're covering. So if we just take BBC news coverage and try to compare with CNN and Fox, it won't give us a very reliable result because the event space has changed. So if we had, say, one more British network where they were roughly covering similar events, then probably we will have something comparable in this space. So these are some of the limitations of this method. And we tried to do cross-platform also. Like we wanted to see, like there was a conservative social media forum, Gab, and we wanted to see if we can compute differences between Gab discussions and Fox and CNN. But it didn't work that well because the event space was very different between this news and other media. But I do like the idea, and I think in future that will at some point that will be feasible.
Okay, thank you. I don't know if there are more questions from the audience.
No, at the moment, no. We don't have any more questions.
Well then I think we had a very inspiring talk. So with plenty of ideas for reading about and trying to do new things. So thank you very much. Thank you very much to the audience and to Professor Ashique. So it was very interesting indeed. And thank you everyone again for this third talk, for coming for this third talk.
Yeah, thank you for giving me this wonderful opportunity, and I hope that you liked the work, and thanks a lot.
Thank you, Professor. Just a note that the talk will be available on our YouTube webpage of CMU Portugal.
One last question.
We have received, yes.
Thanks you for this great talk. Reusing the track political distance among parties during the years. Yeah, so this is also again another limitation of the work. Like comparing across years is different time is kind of tricky because again the event space is changing, right? So That's one of the limitations of the work. And do you think that considering the visual domain would help in detecting biases that go beyond multiple languages and cultures? Yeah, I mean, that's a very, very interesting direction. We focus on text, but I think there are a lot of other signals that we can use uh, in the future. Thank you. Thanks a lot.
Okay, great. Thank you.
Thank you very much, Dan.
Thank you. Goodbye.